geometry students, in this video we will be studying two things. They are called central angles and arcs, okay? Central angles of circles and arcs of circles. Now, both of these obviously deal with circles, and like I told you guys, this entire chapter is going to be about circles and things that deal with circles, okay? Your heading for today is central angles and arcs, and the lesson number is 10.3. And as always, to make sure that your notes are organized, please include today's date, okay? Please include today's date. Central angles and arcs, lesson 10.3, and be sure and include today's date. Now moving on, let's start off by looking at central angles, okay? Now first of all, here's a definition you need to know, so please copy this in your notes. A central angle is an angle whose vertex is the center of a circle, or is at the center of a circle, okay? If that makes it sound a little better, okay? An angle whose vertex is at the center of a circle. That is the definition of a central angle. Please go ahead and copy that down. I'll give you just a minute to do that. Central angle, an angle whose vertex is at the center of a circle. Now, to give you a visual of this, here's what it looks like. So please copy this down. This is a picture of a central angle. There it is. We have circle B. So we have circle B. And this is called a central angle. Angle A, B, C is a central angle. And do you see why? Here's the center of the circle right here. And the vertex of the angle, this part right here, is at the center of the circle. So we call this a central angle. They can be small, or they can be a very large angle like this. Okay? So, this is what we call a central angle. Now, notice something else, however. Notice that when there is a central angle, there's also an arc formed. And let me show you what I mean. Now I'm going to give you a bunch of notes on this. So please, please, please take really good notes, because what I'm about ready to tell you is really important. And also, you're going to have to know the symbolism I'm going to show you and stuff like that. So please take good notes. So students, when I say when there's a central angle, there's an arc, here's what I mean. This central angle really formed two arcs. And you're like, really? Yeah, here's a little arc right here. You see an arc is this length right here that lies on the circle. But another arc was also formed going this direction. Do you see what I'm saying? So, a central angle usually will divide a circle up into two arcs. Now, notice something here, guys. This arc here is called a minor arc. So we denote it using two letters. So arc AC would look like this. Okay, so that symbol right there means arc AC. Now, listen carefully, students. When you see a symbol that says arc AC, you're probably saying to yourself, does arc AC mean this angle? Or does it mean A to C? Or does it mean A to C this way? Which way does it mean? So I'm going to show you right now, so please listen carefully, okay? If it's a minor arc, and if you'll just sit tight and wait, in a second, I'm going to explain the difference between a minor arc and a major arc, okay? But for right now, just listen. If it's two letters, it's a minor arc. Now, if I had a letter here, go ahead and put point D on your circle, students, if you would. If I was referring to the arc that went from here to here, not this arc here, then I would say arc A, D, C. Got it? So let's go over this again. Minor arcs are denoted by two letters, arc AC. Got it? Take notes on that. Write that down. Major arcs you see 2 letters, minor arc, 3 letters, major arc. Now, what is the difference between major and minor arcs? Well, I'm glad that you asked. Please watch carefully and I will show you. Okay, here's the difference. If I were to draw a diameter through the circle like this, and put a point here, we're going to call this point E, okay? I would have, are you ready, students? I would have an arc from here to here. Got it? And what do we call that arc? You know what we call that. It's a word you've heard many times. A semicircle, okay? So, an arc that runs from one end of the diameter to the other end of the diameter, we do not call it a major arc. We do not call it a minor arc. We call it a semicircle. Now, if you want to call it an arc, that's fine. And I've seen some books denote a semicircle by saying arc, E, A, C. And I've seen some books just call it arc, EC. Either way, it doesn't matter because EC or EAC is still half a circle, okay? So it really doesn't matter. But here's what I'm trying to show you. You understand, hopefully, that this is called a semicircle. Now, are you ready? A minor arc is any arc that's smaller than a semicircle. Now, you don't have to necessarily write that definition down because in just a second, I'm going to give you these definitions right over here, okay? But right now, I'm trying to show you. So, a minor arc is smaller than a semicircle. I'll put SC for semicircle. A major arc is bigger than a semicircle. So now you know the difference between a minor arc and a major arc, okay? Pretty simple. So if an arc runs from the end of a diameter to the end of a diameter, we call that a semicircle. And of course, if this is a semicircle, then this is a semicircle over here also, okay? Got it? And any arc that's smaller than a semicircle, like from here to here, we call that a minor arc. However, an arc that runs from here to here, like that, that's bigger than a semicircle. We call that a major arc, okay? Alright, now, let's continue on. Let me tell you some other things about arcs. Something else, students, I need to point out to you is this. Whenever you start at one point on a circle and go all the way around the entire circle, that's 360 degrees, okay? 360 degrees. Now, so common sense would say a semicircle arc measures 180 degrees. Doesn't that make sense, guys? And then if you have a quarter of a circle like this, if I have a right angle right here, and this arc from here to here, that's going to be 90 degrees. So we're going to talk about that in just a second. But the main thing, students, I wanted you to get right here were what a minor arc is, what a major arc is, what a semicircle is, and that when you go the full distance around a circle, that's 360 degrees. And we understand that, okay? Alright, now let's continue on. All of this past information leads me to 3 definitions that, unfortunately, you are responsible for, okay? So here we go. Let's start off with minor arc, the definition of a minor arc, alright? A minor arc is an arc on a circle that is smaller than a semicircle. Now, I know I just told you that back here, but I want to get it in words now, okay? So copy that down. You're responsible for it. Actually, I'm going to go ahead and put 2 more definitions up here and then pause and let you get them down, okay? So minor arc is an arc that is smaller than a semicircle. I told you that already. A major arc is an arc that is larger than a semicircle. I've told you that already. A semicircle is an arc whose endpoints are the endpoints of a diameter, and I've told you that already also. Here's a circle, here's a diameter, so the endpoints of the diameter are here. Any arc that goes from one endpoint of a diameter to the other endpoint, whether it's top or bottom or wherever, is a semicircle, okay? Now I'm going to pause here for a second and be quiet and give you guys about a minute to finish copying these down. Please copy these in your notes. Alright, let's continue on. If you're not done, just continue to copy. These will stay up on the screen for a couple more minutes, okay? Now, let's continue on and talk about measuring arcs, okay? So it's very important you know how to do this, alright? Copy this down. I mean, I'm not going to make this a fill in the blank, but you still should copy this in your notes. An arc is measured by its central angle. An arc is measured by its central angle, okay? I would write that down. I'm going to demonstrate that in just a second. An arc is measured by its central angle. An arc is measured by its central angle. For example, I would encourage you to copy this in your notes if I were you. Okay, here's a circle. Alright, there we go. Now, if I have a central angle right here, that's 100 degrees. Got it? Then we say this arc is also 100 degrees. Okay? So that's simple, guys. So, whatever the central angle is, that's what the arc's going to be. Now, guys, I know we're used to angles being less than less than 180, and I get that, and that's fine. But just understand, just for sake of using 360 degrees, we are going to have some angles now that are larger than 180. For example, if this arc here is 100 degrees, doesn't it make sense then that this arc that goes from here to here is going to be what? 260 degrees. Mr. Earhart, how'd you know that? Well, I just told you, when you start here and go all the way around a circle completely, that's 360 degrees. So if from here to here is 100, then from here to here has to be 260 to make it 360. So this angle right here is really 260 degrees, and you'll get more into big angles like this in calculus, or pre-calculus and trigonometry next year for you juniors, okay, that are seniors next year, for next year. Now, having said that, let's continue on. So an arc is always measured by its central angle, okay? So all you have to do is know what the central angle is, and you'll know what the arc is. And by the way, the opposite is also true. If you know this arc here is 100 degrees, then you know the angle is also 100 degrees. Alright, now let's talk about a semicircle. If you have a semicircle, then you know right away you have a straight line. A straight line is always 180. So the arc from here to here would also be 180 degrees. Okay, students? Alright, now, I'm trying to make this as plain as simple. So I don't care if the angle's really small, like this, and it's 10 degrees, then the arc right here is 10 degrees, okay? And it's common sense also, guys. If you have an arc right here, let's say this angle here is 40, so this arc here is 40, well then the arc from here all the way to here would be 50. You would add those two arcs together, okay? So I'm trying to show you here how we measure arcs, and it's really simple, guys. All you have to know is what the central angle is, and the central angle will be the same as the arc, okay? Now, having said that, let's take a look at a problem, okay? So please copy this in your notes. Here we go. Please copy this in your notes. The best you can. Triangle ABC is an equilateral triangle. So the best that you can, draw an equilateral triangle. The best you can, draw an equilateral triangle, and then draw a circle around it so that we have a circumscribed circle, okay? A circumscribed circle. And then we're going to find the measures of arc AC and arc ABC, okay? So I'll give you about a couple more seconds to copy this down. For those that know how to do this, feel free to go ahead and work ahead. I have no problem with that at all. Please copy this problem down. Find the measures of arc AC and arc ABC, then copy this down. Okay, here we go. Now think about it, students. I want to find the measure of arc AC. Okay, now would you please look at the angle here? Think about this for a second, okay? Now, we know that none of our angles here are central angles, okay? We can see that because none of our angles have a vertex right here. So we got to be really careful with thinking, oh, here's an angle here, and here's an angle here. So the central angle is this angle here. Remember, the arc has to be what the central angle is, okay? So here's my arc. Now I'm gonna put a center here of the circle. Then draw an angle like this, okay? There we go. Now students, please think about it. If I can find this angle measurement here, okay, then I will know what the arc is. Well guys, I'm appealing a little bit to your common sense, which I know we don't always do that in geometry, but let me show you something. If this angle right here is 60, and by the way it is 60 because an equilateral triangle has 60, 60, 60 for its angles, as I take this angle and move it to the middle of the circle, guys, the middle of the circle right here, that means I'm going half the distance from here to here, okay? Well, that means it's going to double. Notice how the angle gets bigger, not smaller. If I were to pull this back to out here, the angle would get really small. Look how small the angle would be. It'd be really small, okay? So if you're going to move the angle from here to half the distance of the triangle, then the angle's naturally going to double to 120 degrees, okay? So here's my central angle. It's 120 degrees. So my arc right here would be 120 degrees. I know you probably can't read that, but it's 120 degrees. So the measure of arc AC is 120 degrees. Now, they want us to also name them or find the measure of arc ABC. So from here to here. Well guys, we know a complete circle is 360. So take 360, subtract out 120, and you're left with 240 degrees for arc ABC. Okay, I hope that made sense. Alright, let's continue on. Now, let's move on now to a postulate. This postulate is really, really common sense, but we will still look at it, okay? And you are going to memorize it, but it's really easy to understand. Here it is. Please copy this down. It's called the Arc Addition Postulate, and I mentioned this earlier. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. I'm going to wait 1 minute while you guys copy this down, okay? Please copy this down, then I'll explain what it means. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Please copy that down. Okay, please finish copying this down if you've not done so. Let me show you what this means. It's really, really simple, and it's really, really common sense, okay? But I would write this in your notes, okay? Alright, if I have an arc that runs from here to here, and then another arc that runs from here to here, I'm just going to use a different color just so you can see it, okay? So I've got a red arc and a blue arc, okay? Now when it says adjacent arcs, it means side-by-side arcs. This is so obvious, guys. All they're saying is if this arc here is, I'm just making this up, 30 degrees, and this arc here is, I don't know, 110 degrees, then the entire arc length from here all the way to here would be 140. You just add the two arcs together. And students, that's really, really common sense. So if you know the arc length from here to here is 30 degrees, and from here to here is 110 degrees, then you know the entire arc length from here all the way to here is 140 degrees. Okay? That's all this postulate is saying. that's really simple, by the way. You could also do it another way. If I told you the whole arc length from here to here was 140, and this much is 30, and I told you to find this arc length here, you would just subtract. If I told you this whole arc length right here is 140, and this much here is 30, then I want you to find this arc length here. You would take 140 minus 30 and get 110. Okay? Pretty simple. Now, this next theorem is also pretty simple to understand, but it's very, very important. So I'm going to spend a lot of time on this theorem, okay? So understand that, and please take good notes. Go ahead and copy this theorem down. In the same circle, or in congruent circles. Now here it is, are you ready? Two arcs are congruent if and only if their central angles are congruent. Now I want to talk about this quite a bit, so I'm going to pause, go ahead and write this down, and I'm going to talk about it in just a minute. Please copy this down, Theorem 10.4. You are responsible for this. And you're also responsible for this. In the same circle, or in congruent circles, two arcs are congruent if and only if their central angles are congruent. In the same circle, or in congruent circles, two arcs are congruent if and only if their central angles are congruent. Okay, now first of all, let's talk about the if and only if part. Okay, now please listen to me. It's saying two arcs are congruent if their central angles are congruent. But it's also saying two central angles are congruent if their arcs are congruent. Okay, so understand what that if and only if is talking about. So let me say that one more time. This theorem is saying two arcs are congruent if their central angles are congruent. It's also saying central angles are congruent if their arcs are congruent, okay? Now, notice it says in the same circle. So let's talk about that, okay? Here's a circle. Got it? In this circle, if I have a central angle of 80 degrees, and over here I have a central angle of 80 degrees, then that means this arc here in green is congruent to this arc here in blue, because we're in the same circle. Got it? Take notes on this, guys. If you're in the same circle and you have two central angles that are the same, then their arcs are the same. And by the way, you could also say the opposite. You could say that if this central arc right here is 80 degrees and the central, I said central arc, sorry, if this minor arc is 80 degrees and this minor arc here is 80 degrees, then this angle here is congruent to this angle here. They're both 80 degrees as long as you're in the same circle, okay? Now, also, let's talk about the fact that you can have congruent circles, okay? So, if this theorem is true if you're in the same circle, but it's also true if you have congruent circles. So pretend for a second that this circle here, now you take notes however you need to, okay? Let's pretend this circle here is congruent to this circle here, even though my drawing's not that good, okay? If I have a central angle here that is 90 degrees, and a central angle here that's 90 degrees, then I know for sure that this arc here is congruent to this arc here. Or you can say it the other way. If I know this arc here is congruent to this arc here, then I know this angle is congruent to this angle. Now to me, that's pretty simple to understand, and it's pretty much common sense, to be honest with you. But I still want to go over this. The two circles have to be congruent, because you see, sometimes students will see this. They'll see a circle like this, and a circle like this. And they'll see a central angle here that's 70 degrees, and a central angle over here that's 70 degrees. And they say, oh, because we have congruent central angles, then this arc here is congruent to this arc here. And that's not true. You have to have the same circle, or you have to have what? Congruent circles. And if you have this scenario here, or this scenario here, then you can say two arcs arcs are congruent if their central angles are congruent, or central angles are congruent if the arcs are congruent. I hope that makes sense, guys. If I'm going too fast, pause the video. Make sure your notes are caught up, and let's continue on, okay? Now, we're going to do what we sometimes do, which is work on the guided practice problems together, okay? So, here we go. Please turn your books to page 495, and let's take a look at numbers 1 through 10 together. Alright, now remember, like always, you are more than welcome to work ahead of me, but please check to make sure you are doing the problems correctly. Now with that in mind, let's go ahead and get started. Here we go. I'm going to go fast, so please pause the video as much as you need to. Question number 1. Name a central angle of circle P. Okay, here's circle P because the center is P. Name a central angle. Well, you could say angle A, P, B is an angle. You could say angle B, P, C is an angle. You could also say a straight angle. Angle A, P, C is an angle. Angle APC is a central angle. It's a diameter. It's a straight angle. It's 180 degrees, but it's still an angle, okay? So any of those three angles would be sufficient, okay? Alright, now, name the minor arcs of circle Q. So here's circle Q. Name the minor arcs, okay? Here they are. This is a minor arc, correct? Sure it is. So we have arc EF. Okay, here's a minor arc, FG. Okay, but there's a third one. I hope you didn't miss it. It's right here. It's not this arc from E to G. It's not that arc smaller than a semicircle. Sure it is. That's smaller than a semicircle. And don't call it arc EFG. Don't do that, because that means that would be a major arc. That's not the right way to symbolize it. Okay, it's arc EG. So there's the three minor arcs that are in circle Q. All right. Okay. Let's continue on now to number 3. Number 3. If I'm going too fast, pause the video. Which arcs are semicircles? Well, remember, you have to have a diameter drawn to have a semicircle. There's no diameter in circle Q, but there is a diameter in circle P. Here it is. So we can say arc ADC is a semicircle. Arc ADC. And by the way, if you put arc AC, I have no problem with that. Or you could say arc ABC. ABC. Both of those are semicircles. Okay, let's take a look here, make sure we got those right. And there they are. Okay, alright, let's continue on now and take a look at number 4. Number 4. What is the major arc associated with angle APB? Okay, let's go to A and P and B. Okay, so there's the angle right there. Got it? Everybody see it? Angle APB. Now the minor arc that's associated with that angle is this arc right here. Okay, but the major arc, which is what it's asking for, the major arc associated with this angle starts at A and goes all the way around to B. So you could call it arc ADB, or you could call it arc ACB. Either one of those two are acceptable, and that's the major arc that's associated with the angle APB. Look, guys, whenever you have a central angle, the central angle makes a minor arc and a major arc, unless it's a diameter. Okay, other than that, it's going to make a major arc and a minor arc. Okay, so there we go, ACB or ADB. All right, moving on to number 5. What is the measure of arc EF? Okay, here's arc EF. Got it? What's its central angle? 40 degrees. So what's its measure? 40 degrees. All right, so the answer to number 5, 40 degrees. Now, what is the measure of arc ACB? So from A all the way to C and all the way to B. What is the measure of that major arc? Well, ask you a question. What's your central angle right here? 40 degrees. So what is arc AB? 40 degrees. So if a whole circle is 360, just take 360 and subtract out 40 degrees, and the measure of the arc is 320 degrees. Okay? 320 degrees. Now, number 7. Name 2 adjacent minor arcs in circle Q. They have to be adjacent minor arcs. Well, arc EF is minor and arc FG is minor, and they're adjacent. That means they touch right there. So the answer would be arc EF and arc FG. Okay? Those two arcs are minor and they're adjacent. Alright? So there we go. EF and FG. Then it says to write, I didn't see this, sorry students, write the arc addition postulate. Sure, no problem. If we take the measure of arc EF, this arc here, plus the measure of arc FG, this arc here, we will get the measure of arc EG, which is what they have written right here. Okay, that's pretty simple, guys. This arc here plus this arc here equals the entire arc from E to G. Okay, and then lastly, let's take a look at this last question here. If PB is congruent to QF, now let's stop right there. Okay, if PB radius is congruent to QF radius. Now stop right there. We learned in our last video, how do we know if two circles are congruent? We said A, if their diameters are congruent, or B, if their radii are congruent. Well, it looks like the radius of this circle is congruent to the radius of this circle because it says so right here. So as soon as I know that the two radii are congruent, I can then say these two circles are what? Congruent. Okay? So now I know the two circles are congruent. Let's continue on. Angle APB is congruent to EQF. So this angle here is congruent to this angle here. Then AB, this arc here, is congruent to EF. Well, students, we just looked at a theorem that said in the same circle, forget that, or in what? Congruent circles. That's what we have. We have two congruent circles. If the central angles are congruent, then the arcs are congruent. So if this angle here is congruent to this angle here, then yes, it is true that this arc here is congruent to this arc here. It says explain. I would just simply say postulate 10.4. Okay, postulate 10.4 totally explains that. Okay, circles are congruent, central angles are congruent, so your arcs are congruent. Okay, guys, I hope this video has been a help to you. Oh, we got 2 more problems, sorry. Alright, 9 and 10, here we go. Determine the arc measure for each time period. Okay, so let's do this very quickly and then we'll be done. Determine the arc measure for each time period. Alright, well, remember, guys, if you'll watch, I'll help you get your calculators out. We're going to use your calculators. Okay, remember, if I start here and go all the way around, that's how many degrees? 360. So when it says this purple part here is 26%, that really means you're taking 26% of the total. So 26% of what? 360. So with your calculators, remember of means multiply. So you take 0.26 times 360, 0.26 times 360, and you will get 93.6 degrees. So this measurement here is 93.6 degrees, this angle here. Now next we have 7%. So we're going to take 7%. I'm going to use ditto marks of 360. So 0.07. Don't use 0.7. 0.07 times 360 gives you 25.2 degrees. So right here we have 25.2 degrees. Okay. Now over here we have 24%. So we're going to take 24% of 360 degrees. So 0.24 times 360 is going to give you 86.4 degrees. 86.4 degrees. Okay? And then I have one more segment left to find. And to be honest, you can do it two ways. You can take 43% times 360, which is fine. Or you can just add all these up real quick. 86.4 plus 25.2 plus 93.6 and minus it from 360, and you'll get 154.8 degrees. Okay? Or you can simply take 0.43 times 360 and you get the exact same answer, 154.8. Okay? So, hope that's made sense, guys. Please continue to study and work hard. If you have any questions, don't hesitate to call or email.